Hello children, this is your physics teacher Sharma and I welcome you all to today's class. In the previous class, we have discussed about sound. We have learned that sound cannot travel in vacuum and it needs some medium for its propagation. And we have also learned how our ear can make the sound heard to us. As a part of that, we learned about eardrums which actually vibrate whenever there is a sound produced, and that will be sent in form of a signal to the brain. Now, in this class, let us know about the nature of sound. Students, sound travels in form of a wave. Okay. Whenever we consider or whenever we use this word wave, what immediately comes into our mind? Water waves, isn't it? So, here, this also is nothing but a wave. Sound is also a wave, just like a water wave. Except for, in case of water waves, we can see the particles or anything which is floating on the water moves up and down. Whereas in case of sound, the particles will be moving forward and backward. And when I say forward and backward, this kind of motion actually we have discussed in the previous class. I hope you remember the word vibration, and along with that we have learned oscillation. In your textbook, it is mentioned that this to and fro motion of an object is called vibration, and it is also called oscillation. Yes, we take the statement given in the textbook for granted for now. However, when you go to higher classes, you will know that vibration is slightly different from oscillation. Now, coming back to topic, oscillation. It's a to and fro motion of an object. Now, when I am talking, what actually is happening? The particles which are there in front of my mouth, these air particles which are there in front of my mouth, they are moving forward. When these particles are moving forward, they are pushing the air particles which are there in front of them. Okay. Now, after colliding with those particles, they bounce back. So, these particles are moving forward. They are colliding with another particle and they are bouncing back, coming backwards. They are colliding with another particle and again moving forward. So, it is making a to and fro motion. Okay. So, these particles are undergoing to and fro motion, which we can say either vibration or, according to your textbook, oscillation. Okay. Now, these waves I can represent in form of a sine wave. This kind of wave is called a sine wave. I will represent, for my convenience and for your easy understanding, I will represent the sound wave in form of a normal wave, which we all know. Okay. With help of this diagram, we can understand the characteristics of sound waves. First one is the amplitude. Okay. Amplitude is nothing but the maximum displacement undergone by the particle. Remember, when I am talking, the air which is forced through the voice box from the lungs is making a sound, and that same air is coming out of my mouth. That is actually disturbing all particles which are there around my face. Okay. If suppose you are above my head, then you can hear the sound because my voice, the wave which is coming out of my mouth, is actually disturbing the particles which are above my mouth also. Okay. If this is the mouth, okay, then waves are traveling like this. Okay, so they are disturbing particles which are all around them. So automatically it would be heard. Now, whether it is heard loudly or it is feeble, it depends on how much energy that particle is advanced with. Okay, or rather, how much displacement that particle is undergoing. Now, as I said, the particle which is in front of my mouth, it travels forward and again comes back, isn't it? So, this particle which is here in front of my mouth is moving forward, it is stopping there and is coming back. This displacement undergone by the particle of the medium is called amplitude. Initially, let us assume this is the position which we say mean position or zero position. When there is no force acting, when there is no disturbance created, the particle was here. Now, when some sound is produced, that particle started vibrating or oscillating. Now, this particle from here, it has undergone displacement to this point. So, that displacement undergone by the particle, to be more precise, the maximum displacement undergone by the particle of the medium is called amplitude. So, how do we define amplitude? It is the maximum displacement undergone by the particle of the medium. Okay. Now, coming to time period. This you will be able to understand if you consider a simple pendulum first. Let us assume I have a small simple pendulum. Now this is in its mean position. When I set that to oscillation, from mean position it went to extreme. From there it is undergoing to and fro motion. Okay, so it is oscillating. Now, starting from this point, going to the other extreme position and coming back to the initial position, this makes one oscillation or one vibration. Starting from the extreme position, going to the opposite extreme position and coming back to initial position. Okay, that is making one oscillation. It started here, it went to other point and came back to the same point, starting point. So this is making one oscillation or one vibration. Time taken to complete one oscillation or one vibration is called time period. The name itself says time period. It is nothing but the time taken. Time period is nothing but the time taken to complete one oscillation or one vibration. Okay, and this time period is usually measured in seconds. Okay, while amplitude is measured in meters with its SI unit, time period is measured in seconds. Now coming to frequency. This word frequency is something which we come across in our normal terminology as well. We use the word, like we use this phrase, buses frequently come. Okay, the municipality truck frequently comes to collect the garbage. So these kind of phrases we use, and that is when we come across the sentence or the word frequency. Okay. If we closely observe, this word frequency is very simple to understand. The number of times that event is taking place. If we consider the bus coming to the bus stop is an event, then the number of times the bus coming to the bus stop is the frequency. If we consider the municipality van coming to collect the garbage as the event, in 1 week, how many times the municipality van is coming to collect the garbage is giving you the frequency. If we are considering completing one oscillation or one vibration as the event, in 1 second, how many vibrations are completed. That will give us the frequency. So frequency is nothing but the number of vibrations or number of oscillations completed in 1 second. Okay. So amplitude is the maximum displacement undergone by the particle. It is denoted by the letter capital A. Time period is the time taken for completing one oscillation or one vibration. It is denoted by the letter capital T. Frequency is the number of waves produced in 1 second, and this is denoted by the letter N or a Greek alphabet nu. Okay, we can use either of these, either N or nu. Okay. Now coming to loudness. My voice could either be loud or it can be very feeble, like how I am talking now. It may not be very loud. It is so feeble that even you may not be able to hear that. What difference do you find? The loudness, isn't it? The previous one, it was very loud that you could hear it very clearly, and when I slowly decrease something, the loudness decreased. Now what is it I have decreased? Okay, actually loudness is nothing but the amount of energy I am putting in to produce the wave. In other words, that is the amplitude. So loudness is dependent on amplitude, and it is actually dependent on square. It is proportional, directly proportional by its square times. That means if the amplitude is increased by 2, the loudness will increase by 4. Okay, so loudness is directly proportional to amplitude. If the amplitude increases, the loudness also increases. That means if the particle is traveling more distance, okay, that means the displacement undergone by the particle is more. That means it is having more energy, and that is when it is able to travel far, and even the person who is sitting in the last row will be able to hear it very loudly. If that amount of energy is not supplied by me, if I am giving very little amount of energy, then the particle will not undergo maximum displacement. Okay, very little displacement it undergoes. So only the first 2 rows will be able to hear me, and the last row will not be able to hear what I am saying. Okay, so that is loudness. Now what is pitch? Pitch is otherwise called as the shrillness. For this I have an example which we commonly notice. Most of the times we see auto rickshaws, they play music. Okay, and that music will be having a very big speaker which produces the sound of drums, and they also have very small speakers which we call it as a tutor or a tweeter, and that usually makes the sound of bells. Okay, let us assume you are standing by the roadside and an auto which is playing music at its highest volume passes you by. Okay, now after a certain distance, which sound will you be able to hear clearly? Is it the sound of the drums or sound of the bell? If you have noticed this before, if you had an experience of this before, you would be able to hear the sound of bells even from a longer distance. Okay, that is because bells will have a high frequency when compared to drums. Okay, bells will have a high frequency when compared to drums, so they are very sharp and we can hear it from a longer distance. Okay, for example, if we take a boy and a girl standing at a certain distance, maybe 100 meters away from me, and they both talk with the same loudness, I would be able to hear the girl's voice very clearly, Because girls will have a high pitched voice, or their voice is more shrill when compared to boys' voice. Okay, so the shrillness or the pitch is actually dependent on the frequency of the wave. So these are the characteristic properties of a wave and also the sound wave, which we can interpret to sound wave. Okay, so make it a point that you write the explanation for each and every side heading I have given, following the video carefully, and you can forward the notes to me. See you again in the next class. Until then, have a nice time. Bye bye.